cultures. It's described in the Kabbalistic tradition and so on.
How big,
So
how big is it?
it's very small.
It's very small.
Yep.
Like smaller than this? I mean, like,
There's different scales of it. Depends what you want to do with it. So let's say you wanted to power a ship the size of the Earth.
yeah.
You could probably make one that's the size of a basketball and do the job.
Okay, well, then,
You're basically building a singularity in a can, a little black hole.
I'm trying to keep the mic.
Right.
You probably already answered it, but if you're challenging dark energy and dark matter, and that's their new theory for the expansion of the universe, what are you putting in place of it for what the evidence they have for the expansion of the universe? That's
Right. Okay, so well, that's a very complex question, but basically what happened is that Einstein, threw in a constant in to get a static universe. And then Hubble found that the universe was expanded. So they took the constant out, right? As far as I'm concerned, that's not appropriate physics, but anyway. And then what they found is that the universe is accelerating as it expands, right? It actually violates, Newtonian second thermodynamics law. And it's accelerating, so instead they added the constants back, and they added enough energy to make it do that. So basically, you know what I'm saying? And so what I'm proposing in my torque paper, I publish a new solution to Einstein field equation that includes torque and Coriolis forces in space-time. Currently, the current concept is that our universe is not rotating. Okay, that's one of the fundamental problems. Imagine, everything is rotating, but our universe is not. Right. Well, in this view, the universe is rotating, and space-time applies torque and Coriolis forces on the system, meaning Einstein said that gravity is the result of space-time curving, right? To create gravity, like an object is attracted to another one because of the curve of space-time. What I said in that paper, really, is that space-time curves and curl, spins. And that's the missing energy. So imagine that you are analyzing the wheel of a car that goes from point A to, on top of the hill there, point B. Okay? And you're trying to figure out how it got there, and you analyze all the energy in the tire, all the energy in the rim, all the energy in the axis and the bearings and all this stuff. And then when you finish with your calculation, you're still missing 90-some% the energy you need for that to happen. Well, that's because you forgot to include the torque produced by the V8 engine that turns that wheel. Right? If you don't include the torque, if you don't include the Coriolis forces, if you don't include the engine that runs all that, you're going to be missing the large part of the energy you need to make that happen. That's what I'm saying. It's like they lost the Newtonian mechanical function of space-time along the way, and that's what created the error in the mathematics. It's not something out there that we can't see that makes up the rest of the energy.
Hey. Well, back here. Wonderful thing, when I was in school, they told me 0.999 with the line over the top equals 1. That's when I went out of the box. Wouldn't it be, I kind of find it funny with super colliders, they're trying to create, mini black holes and white holes now. Wouldn't it be, isn't that already happening? Wouldn't it be a lot harder to try and prevent them? But you touched on what I wanted to ask, which is that they have discovered that the universe is expanding at an accelerated rate. Is that not at some point going to define an outer sphere for the universe where everything reaches light speed?
Yes, that's a good question. That's assuming an open universe. They assume a closed universe. So, but what it's a very good question. Let's go back on that question and say, okay, you're saying, I am, that the universes are fractal in nature, and that everything is embedded in each other. Okay, well that means that the Earth is spinning around the Sun at a certain speed. The Sun is spinning around the galaxy at a certain speed, which is, I think, like, I can't remember. And then the galaxy is moving through the cluster, and then the cluster is moving through the universe. If you add those speeds, right, and there's a universe within a universe within a universe, that means that eventually you reach the speed of light for everything. See what I'm saying? So yeah, I am saying that. I am saying that everything is moving at the speed of light, and that's why there is that special relativity thing in which light appeared to move at a constant speed in all directions, okay, from a point of observation, right? It's because that we are actually, you are right now moving at the speed of light. I'll give you an example. So then you're going to say, well, what the heck is movement then? What are you talking about, right? Well, I'll give you the example of why we're confused about this. Because we think movement exists, and it doesn't. If everything is embedded in each other, movement doesn't exist. All you got is fluctuations. So, you look at your hand, and you say, my hand leaves point A and goes here, point B, right? And it's got linear motion from here to there. But if you actually look carefully with the quantum eye, and you went in there in the small particles, actually your hand didn't do any of that. In fact, your hand deconstructed itself and reconstructed itself and deconstructed itself and reconstructed itself. And it's happening so fast that you can't tell. And your intent is making it reconstruct in the vacuum at the right place. Because you're moving billions of atoms, right? Billions of atoms. There was researchers, you know, there was researchers that were talking to me about studies that were made about measuring intent. I'm like, looking at them going, watch this. I'm moving billions of atoms with my intent. You think that's cool? You know, so like, what, you know, that's, you know, let's get beyond that and like realize like that's happening, and movement is just a concept. It's like a movie, right? In a movie, you only see, you don't know if you don't have the movie stop that there's frames, no frame, frame, no frame, no frame, no frame, right? But it looks continuous to you, and you would think that's movement, right? But there's no such thing. There's just construction, deconstruction, construction, deconstruction, quantum leaping everything across space-time structure.
Yeah. Oh, she wants me to stand up. Okay. Yeah, I'm glad you brought up that point, because that gives us a whole new perspective, the mind that I share with you, on teleportation. We are teleporting all the time.
All the time.
So why not extrapolate that up into greater teleportation?
Right.
Going back to the beginning of your talk, the thing you that started you on this with the points, the lines, et cetera, I think what Edwin Abbott and Rudy Rucker and things like Flatland and the Fourth Dimension, excuse me, what they are is they are encouraging us to think differently, to go way out of the box, to expand our way of looking at it. And there are things, a couple of my favorite things are Mobius strips.
Right.
Klein bottles,
right?
A tesseract. I have a tesseract on my wall. And what I found out is that instead of just playing with them, if you look into them, if you make yourself small enough to walk the edge or the surface, the single edge or single surface of a Mobius strip or a Klein bottle, or if you look at the tesseract until all sorts of three-dimensional rooms and stars and figures start coming out in it, you have a wonderful series of tools are all around.
Right.
Yeah.
There's evidence of that infinite loop of creation everywhere. And that's a good point. And to like observe it and to realize it. To realize it. I mean, what I was saying on movement, for instance, to realize that. You know, dancers and so on. To realize like the miracle of you doing this. I mean, whoa. You know, it's an amazing thing. Because everything is spinning everywhere, and you're embedded in it, and you're moving at incredible speeds. And so, you know, you're actually ultimately absolutely still in every moment. And each of these moments are piled up so that you think that there's a linear function to it. Okay. And that has implication to time as well, and the concept of linear time. Go ahead.
Yes. So you're saying that we are the resistor between the energy information that goes within